In this video, we're going to be looking once again at the absolute value function. However, we're going to look at how you can put it in hybrid notation. So what I mean by that is rather than having y is equal to modulus x, then you can put it in a form where you have y is equal to the hybrid or piecewise function in which you have x, and you can have a different formula here such as negative x, but you have different domains such as there. So that's what I mean by like hybrid notation. So you can remove these modulus signs, rather put them as different functions and then have different restricting domains that show this. So for this case, you can see that, remember, this is y is equal to modulus x, and then it's governed by y is equal to x for when x is greater than 0, as you can see this, because that's y is equal to x. However, it's not governed by this equation when x is less than 0. It's rather governed by y is equal to negative x when x is less than 0. And I'll show that's why the case later on. So looking at the modulus function, or the modulus 2x minus 4. Now, you can think about this. When this number here is positive, so the final result, I mentioned this before, like you have to think about the final result rather than just the x value. So when the final result is positive, then 2x minus 4 is just equal to 2x minus 4. And that's because a positive number, so let's say positive a, will just always equal a. So it's the exact same. So that's when the final result is positive. Then when the final result is negative, so let's say 2x minus 4. So whatever number is in here is negative. So let's say we have modulus b. So modulus, if b is negative, so here's a negative number, the modulus b is equal to negative b. You can think about that as in, if you have an example, modulus negative 2, that is equal to negative 2, which is equal to 2. And that's because a negative and a negative make a positive. So if b is a negative number, then negative b will just give you positive b, or the modulus of b, the magnitude of b. Another example, like negative 5 would equal negative 5, which would just equal 5. So we can say is that, going back to this example, that 2x minus 4, when this is negative, so the final result is negative, is equal to negative 2x minus 4, which is equal to negative 2x plus 4. So we can see that there are two different equations that it's governed by. But now we need to know for what x values, what values which will produce a result which is positive, and then we can say it's governed by this function, and then for what x values give a negative result, then we can say that it's governed by this equation here, i.e. the negative of the modulus. So we have the modulus of 2x minus 4, and then we can say that this is equal to a hybrid function of 2x minus 4 and negative 2x minus 4. But this is when the result is positive, so a result is positive, and this is when the result is negative. So what are the particular x values for that to occur? Well, that means 2x minus 4 must be greater or equal to 0. So 2x must be greater or equal to 4. So x must be greater or equal to 2. So we can say x is greater than or equal to 2. Then negative 2x minus 4. So that means 2x minus 4 is less than 0. So 2x is less than 4. So x is less than or equal to 2. And then we just say x is less than 2. Now you need an equal sign here, so an equality sign for one of them, but it doesn't matter which one it is. And the reason for that is if you can remember, a modulus function will look like that, or have this sort of sharp point, and that's when these two connect, and that will be when x is equal to 2. And that's sort of all cases, there will be a common meeting point, and so that common meeting point will be when these two values, no matter what equation you look at, either this one or that one, you'll still get this value. So you just do need to put the equal sign on one of them. However, you can put them on the 2, which is common standard, like x is greater than or equal to something, or you could have put it on that one. So for here, you could just get rid of that. Or you could put it on, but then for this one, you would have to remove it. So a few things. Just went up with the negative, as we'll show with an example later, but just to note now, that the negative sort of only refers and only relates to what's in the modulus. So you don't put the negative in the entire function. For this case, it is because it's only modulus. But if there was a function without the terms that are not in the modulus, then you wouldn't put the negative for them. So it only refers to what's in the modulus sign. And then you can simplify that by saying negative 2x plus 8. So plus 4. So assuming we have an equation, y is equal to the modulus x squared minus 5x plus 4. And we have to put this into a hybrid form function. So we want y is equal to the hybrid form in which you have an equation governed by the domain and an equation governed by a domain. Now firstly, we know that when x squared minus 5x is positive, it's just equal to x squared minus 5x. And then when x squared minus 5x is negative, it's governed by negative x squared minus 5x, which simplifies to negative x squared plus 5x. So we got the two different equations. But then when is this inside positive and when is this negative? So this is positive when x squared minus 5x is greater or equal to 0. So x squared, you can put it into x minus 5 is greater than equal to 0. And the easiest way to see this is if you graph it. So graphing it, we know there's an intercept at 0 and there's an intercept at 5. And then when x approaches infinity, y is going to approach infinity. So the graph looks like this. So from visual inspection, we know that y is going to be positive when the value is greater than 5 or less than 0. And you can work that out by thinking that when it's positive, this value needs to be positive as well as this value, and that occurs when x is greater than 5, or this value needs to be negative and also this term needs to be negative because two negatives make a positive, so that means x has to be less than 0. Because when x is less than 0, both these terms will be negative, so therefore we'll have a term which is greater than 0. So over here, we know that x has to be greater than 5 or greater or equal to 5, or x has to be greater or equal to 0. So that means we can just, with the negative, we can calculate it by going x squared minus 5x is less than 0. But from this graph, we can see that it occurs in between these two values. So we know that x has to be greater than 0, but less than 5. So we have 0x 5, and up here we have x has to be greater than 5 or x has to be less than 0. So there are multiple notations of writing this. Now here we have x squared minus 5x plus 4. And over here we have negative x squared minus 5x, but we still have plus 4. And this is a really important thing to note, that the plus 4 remains there. The negative only affects the modulus sign, and that's because y is always going to be plus 4 no matter what it is. So if the modulus changes the value inside, it doesn't affect the plus 4 because the plus 4 is outside. So with a negative, you put the negative brackets everything inside the modulus, so all this value here, but you keep the plus 4, or if it was a negative, you keep it a negative number. So with the final result, we can say that y is equal to x squared minus 5x plus 4 when x is greater or equal to 5, union x is less than 0, or negative x squared plus 5x plus 4 when between 0x and 5.